We're going to look at another example of completing the square. So let's say that we're given the equation 2x squared minus 3x minus 1 equals 0. Now remember, the standard form of a quadratic is ax squared plus bx plus c, but we needed our a term, or our coefficient of x squared, to be equal to 1, and here it is not 1, it is 2. So we have to divide 2 through all our terms to get rid of it. So we have a coefficient of 1 here. Okay, so on this example, my first step is to divide everything by 2. Okay, so 2 divided by 2 reduces out. Now I've got x squared minus 3 halves x minus 1 half equals 0. Now my coefficient is 1 in front of x squared. So I'm going to take my c, my negative 1 half, and I'm going to add it to both sides of the equation to just move it to the other side of the equal sign. So plus 1 half plus 1 half. Now this will add up to 0, so I am looking at x squared minus 3 halves x equals positive 1 half. Okay? And remember, the process for completing the square is to take my b, divide it by 2, and then square it. Here my b is negative 3 halves, so I've got negative 3 halves divided by 2 squared. Once again, remember, when you have fractions inside fractions, you want to take the reciprocal of the bottom and multiply it back to the numerator. Okay, now that I've taken the reciprocal of the denominator, looking at what I have inside, nothing is going to cancel out, so I can just multiply straight across. So I've got negative 3 times 1 gives me negative 3. 2 times 2 gives me 4. And then I need to square it. Okay. Negative 3 squared is positive 9. 4 squared is 16. So this is my factor. This is what I add back to the equation. So, let me make sure my paper's straight. Now I'm looking at x squared minus 3 halves x plus 9/16 equals 1 half plus 9/16. Okay. I know now this is a perfect square trinomial, and this is my factor. So I have x minus 3/4 times x minus 3/4 equals 1 half plus 9/16 is 17/16. Okay. My set of parentheses here are identical, so I can rewrite it as 1 with a square on it, and that is still equal to 17/16. And now I have something squared equals to a number. I can use my square root method. Remember to add your plus or minus sign. We cannot forget about that. Okay. So the entire point was so that my radical would cancel out my square, and now on the left-hand side, I have x minus 3/4 equals to plus or minus square root of 17 over 16. Right here in the corner, I'm going to simplify my square root of 17 over 16. Because it's a fraction, I can break up the radical to the numerator and denominator. So the square root of 17 over the square root of 16, and I know the square root of 16 is 4, and the square root of 17 is not something I can simplify. I don't want to change it to a decimal because I'm working with fractions here, so we're going to leave it the square root of 17 over 4. So going back to my equation, I'm looking at x minus 3/4 equals plus or minus the square root of 17 over 4. Okay. Let me move this up and get some new paper. So I'm going to go ahead and break this up into two different equations now because I do have two different solutions here with my plus or minus sign. So I have x minus 3/4 equals negative square root 17 over 4 and x minus 3/4 equals positive square root of 17 over 4. Okay. So just working with one equation at a time this time. To solve for x, I need to add my negative 3/4 to both sides. So let's do that. Plus 3/4 plus 3/4. This adds up to 0, so I'm looking at x equals 3/4 minus the square root of 17 over 4. Now, for some instructors, this might be enough of a solution to stop, but our fractions here have the same denominator, so we can rewrite it as one fraction. X equals 3 minus the square root of 17 all over 4. Okay? This is what we call an exact answer when it involves a square root like this. We don't want to do anything to change it. We don't want to change this into a decimal approximation. We just want to leave it how it is. Okay? So now looking at the other equation, I still have my 3/4 here, and I still need to add it to both sides. So now I have x equals 3/4 plus the square root of 17 over 4. And just to write it as a single fraction, I check my denominators. They're both the same. So I can rewrite it as x equals 3 plus the square root of 17 all over 4. Okay. So this looks like a messy solution, but it's really not. You're more than fine to stop right here. So we're done.